This video is on domain and range. This example is a continuous graph with only one endpoint, so it continues forever in the other direction. So it will continue forever in one direction. So we have our information about the domain and range on here. I'm going to focus on the graph and focus on this note. So the first thing for our domain and range, I'm going to focus on the domain first. I want to write this in interval notation, and then I will write this in set notation as well. So as before, my domain I'm going to continue using blue for. So I'm going to highlight for the domain the farthest point to the left, which happens to be this coordinate right here. There's nothing else to the left that this graph contains. Then I want the farthest right point, which in this case is going to be an arrow. So I'm actually going to highlight the arrow because that is the farthest thing to the right. Now what this represents, the coordinate for this point, the x value is 0. So I'm going to write the 0 next to it. The arrow represents it's going to keep going forever. Now, if it keeps going forever, it's going to reach infinity, which never actually gets reached. But if it's going to the right-hand side, it's actually going to keep going towards that positive infinity, because it never actually stops. So our domain wants to go from 0 to that positive infinity. And we always look to see from blue to blue, from the highlight, will I have to pick up my pen if I wanted to keep going? I do not have to pick up my pen, so that's a continuous graph. Discontinuous graphs are when you have to pick up your pen or pencil to start the other part of the graph. So for us to write our interval notation, we would start with our smallest value, which is our 0. It is closed at that coordinate because it is actually stopped there. Then we want to write our highest value, which will be that positive infinity. Positive infinity can never be reached, so that will be an open bracket. So when we look at our domain in interval notation, we write it as close bracket 0, comma, infinity, open bracket. You can put a positive sign with that infinity to remind yourself that this is a positive infinity. We also want to write this in set notation. So for set notation, I'm just going to write it up here. I'm going to have my squiggle bracket. It's going to be x such that, because I'm dealing with domain. Now, because I only have one endpoint and it goes on forever, I know that I don't want to try and go between two numbers. So I'm actually going to have only one inequality. So I'll actually start with my x values, because my x's are either going to be bigger or smaller than something. The one number that we actually have that's an actual number that we actually know the value of is 0. So I'm going to put my 0 here. Now I have to figure out the inequality. Because I'm going to go to the positive infinities, I want all the numbers that are bigger than that 0. And because it's a closed bracket, I can include that in my inequality. So I want the x values that are greater than or equal to 0. And that will be our domain. So then if we focus on the range, we'll do the same thing with I'm going to use my pink highlighter for range, but this time we're going to focus on the lowest point of the graph and then the highest point of the graph. So on this graph, my lowest point is, again, the same coordinate I've already highlighted, and then my highest point on the graph is that arrow that's pointing upward. So I'm going to highlight that in pink as well. So my y value, that smallest, is also 0. So I'm going to put that 0, that is my smallest y value. And then my highest y value, because it's going to keep going up forever, that will still be a positive infinity. So our range for interval notation, the smallest y value is 0, and the highest will be positive infinity. So we'll go from 0, comma, positive infinity. It is a closed bracket on 0 because it stops there, or it starts there, and it will be an open bracket on infinity because it will never actually reach infinity. So we would write our range in interval notation as close bracket, 0, comma, positive infinity, open bracket. To write this as set notation, I'll write it here. We'll have our squiggle bracket. I want my y's such that, because now I'm talking about my range. Again, because we have only one number and it goes forever in one direction, I'm only going to have one inequality. Therefore, I'll put my y's first. The only number we have that we know the value of is 0. So I'm going to put my 0. For the inequality, I want the numbers that are bigger than the 0 because it's going to that positive infinity. But we can also include that 0 because of the closed bracket. So we would want y is greater than or equal to 0. And that is our range. So one important note that we do want to put over here, this one we had the arrow pointing up and to the right. So that gave us the up was the range had a positive infinity, and to the right, the domain had a positive infinity. We're going continuously forever in this direction. If the arrow were pointing to the left, so this note, if the arrow was pointing to the left, but let's say it was still pointing up, then the domain would actually be less than or equal the x values, because we would actually be going to the negative x values. So we would want to go smaller. But the range would have still been the same because it would have still been pointing up. However, if the arrow were pointing down, then the range would be less than or equal the y value, because it would be pointing, the range would be pointing to the negative infinities. So this arrow could actually be pointing in different directions. Because it's pointing up and to the right, both of them are positive infinities. If it was pointing up and to the left would be a negative infinity, but the up would still be a positive infinity for the range. This graph also could go into quadrant 3 and could have been pointing down and to the left. Down means the range is negative infinity, and left means that the domain is negative infinity. If it had been going through quadrant 4, it would have been pointing down and to the right. So the right-hand side would still be the domain is positive infinity, but the range would be negative infinity. So the arrow means we're going to have an infinity. We just have to determine which direction is it pointing in. So domain, is the arrow pointing left or is it pointing right? For the range, is the arrow pointing up or is it pointing down? So we need to know which infinity it will be. But if there is an arrow, we're going to have a less than or greater than symbol for the value of the number that we have.